Let's solve this algebra problem carefully and see how many values of m satisfy the equation. And we are given m multiplied by m multiplied by m multiplied by m, all divided by the sum m plus m plus m plus m plus m plus m, and that is equal to 216 divided by 6. Before we continue, pause the video for a moment and see if you can find the answer on your own. And when you have an answer, let me know in the comments, because I'd love to see how you approached it. Now, let's begin. First, look at the numerator. Since m is multiplied by itself 4 times, we can write that as m raised to the power 4. Next, let's simplify the denominator. We are adding m together 6 times, and repeated addition of the same quantity is simply multiplication. So the denominator becomes 6 multiplied by m. On the right-hand side, 216 divided by 6 is equal to 36. So our equation now becomes m raised to the power 4 divided by 6m equals 36. Now, let's look at this step carefully. There is a common factor of m in both the numerator and the denominator. So as long as m is not 0, we can cancel one m from the top and the bottom. Notice that if m were 0, the original denominator would also become 0, making the expression undefined. So 0 is not a valid value anyway. After canceling, we are left with m cubed divided by 6 equals 36. To remove the denominator, we multiply both sides of the equation by 6. The reason we do this is because multiplying both sides by the same non-zero number keeps the equation balanced. 6 on the left cancels with the denominator, giving us m cubed equals 6 multiplied by 36, which is 216. Now notice something very useful here. 216 is exactly 6 raised to the power 3, so we can rewrite the equation as m cubed equals 6 cubed. Next, move everything to one side of the equation so that we have m cubed minus 6 cubed equals 0. Now, pay attention because this is a standard algebraic identity called the difference of two cubes. The identity tells us that a cubed minus b cubed can be factorized as a minus b multiplied by the quantity a squared plus ab plus b squared. Applying this identity with a equal to m and b equal to 6, we get the factorization m minus 6 multiplied by the quantity m squared plus 6, m plus 36 equals 0. Now we use the zero product property. This property says that if the product of two expressions is 0, then at least one of those expressions must be 0. So either m minus 6 equals 0, or m squared plus 6, m plus 36 equals 0. Let's solve the first equation. Adding 6 to both sides gives us m equals 6. This is our first solution, and we'll call it m1. Now let's solve the quadratic equation m squared plus 6, m plus 36 equals 0. We'll use the quadratic formula because this equation does not factor nicely over the real numbers. First, compare it with the standard form, ax squared plus bx plus c equals 0. From this comparison, we identify a equals 1, b equals 6, and c equals 36. The quadratic formula tells us that x equals negative b plus or minus the square root of b squared minus 4 multiplied by a multiplied by c, all divided by 2 multiplied by a. Since our variable is m, we write m equals negative 6 plus or minus the square root of 6 squared minus 4 multiplied by 1 multiplied by 36, all divided by 2 multiplied by 1. Now, simplify step by step. 6 squared is 36, and 4 multiplied by 1 multiplied by 36 is 144. So, inside the square root, we have 36 minus 144, which equals negative 108. Therefore, m equals negative 6 plus or minus the square root of negative 108, all divided by 2. Now, let's simplify the square root. Negative 108 can be written as 36 multiplied by negative 3. Using the property of square roots, we separate this into the square root of 36 multiplied by the square root of negative 3. Then we write the square root of negative 3 as the square root of 3 multiplied by the square root of negative 1. The square root of 36 is 6, and the square root of negative 1 is the imaginary unit I. So the square root of negative 108 becomes 6. A square root of 3. Substituting that back into the formula gives m equals negative 6 plus or minus 6, I square root of 3, all divided by 2. Now, divide every term in the numerator by 2. Negative 6 divided by 2 is negative 3, and 6 divided by 2 is 3. Therefore, the remaining two solutions are m equals negative 3 plus 3, I square root of 3, and m equals negative 3 minus 3, I square root of 3. So altogether, this equation has 3 solutions. The real solution is 6, and the two complex solutions are negative 3 plus 3, I square root of 3, and negative 3 minus 3, I square root of 3. Before we finish, let's quickly verify the real solution. Substitute m equals 6 into the original equation. The numerator becomes 6, multiplied by 6 multiplied by 6 multiplied by 6, which equals 1,296. The denominator becomes 6 plus 6 plus 6 plus 6 plus 6 plus 6, which is 36. Dividing 1,296 by 36 gives 36. On the right-hand side, 216 divided by 6 is also 36. Since the left-hand side equals the right-hand side, our real solution is confirmed to be correct. If you found this explanation helpful, don't forget to like this video because it really supports the channel. Subscribe for more interesting mathematics problems. And let me know in the comments whether you found the real solution first or if you noticed the complex solutions as well.